All right. Well, welcome everyone. Thanks for joining us today. To start off, we need to acknowledge that the Mallee Catchment Authority and the National Land Care Program have given us funding so that we can run this workshop. And I'd also like to thank LaTrobe University, who's James Hunt and Rees for their time and expertise today, as well as Kate Maddern from BCG, who've put a lot of work into organising this. We know that using an online platform is a bit different to face-to-face meetings, so there's a few things you need to do that we can make things run a bit more smoothly. Make sure that you've got your microphone on mute at all times if you're not actually contributing, and use the chat box on the side to type questions or post relevant information if you have it for the workshop. On the back end, I'll do my best to pass those questions or comments onto the presenters if we feel it's necessary. The workshop today is going to be about an hour and a half. Harm and James are going to give you an introduction to soil organic matter, relationship with nitrogen. Kate's going to give you an outline of the trial being undertaken by BCG and some of the results in 2019. You'll get a background into N mining and crop production and building soil organic matter as well. We're going to jump into some N budgeting and balancing examples, and follow that we'll have a Q&A session. During the Q&A, we'll get you to raise your hand using the function on the Zoom taskbar, and then we'll pick you out to ask questions that if you want, and then we'll answer them out loud. If we don't get to your questions, please post them in the chat box. We'll compile them at the end of the workshop. We'll get Harm and James and Kate to give their expertise to answer them, and we'll send those answers out to everybody who's here today. So if you hadn't already registered your email address and you've jumped on through the GAP group or another method, send us your email in the chat function so we know how to send out the answers to you. I'm going to post a link in the chat box now so you guys can see it. This is a Padlet, which is a link that you can go to put a geo spot to show where you are in the world, which gives us a good little readout to show our funders where the reach of our workshop. I'll now hand over to James, Harm and Kate, who are going to take you through everything. So good luck to you, and I'll be turning my screen off and working in the background for now. James?
Cool. So I'll share my screen in the latest version of the PowerPoint. Is that the thing to do?
Absolutely. Yep.
Cool. Can I share my screen? Yes, I can. Sorry. Okay, can people see a PowerPoint presentation there?
Yep.
Yep. Okay. Okay, has that come up as a presentation and everyone can see clearly?
Yep.
Yep.
And you can see the laser pointer?
Yes.
Okay, thanks everyone. Okay, so Tom gave you the quick introduction about what we're going to, about the webinar. I'll start by giving a brief outline of what we're going to talk about today. First of all, we're going to spend a little bit of time going back over what soil organic matter is and why we care about it, and particularly how, thinking carefully about, because we often talk about soil organic carbon and soil organic matter interchangeably, but just get very clear what those differences are there and what the relationship is with nitrogen in our cropping systems. And what we're going to try and communicate is that there's sort of two roles that nitrogen plays in our cropping systems, or fertilizer plays, and one is about fertilizing crops to achieve their yield potential in a given year. And Harm's going to talk about that and give an example. We're going to work through an example of an N budget with a spreadsheet we've developed. Tom, have you sent the spreadsheet round to the participants, or will that happen afterwards?
You send it out, James. Yeah, it should be in their email from me. If you haven't got it, please post your email into the chat box and I'll send it through now.
Cool. And yeah, we'll work through an example, but you're welcome to take that spreadsheet away and plug your own numbers into it, or even plug your numbers in while we're working through it. Then we're going to talk briefly about calculating a nitrogen balance. So a nitrogen budget's an annual thing where you're working out how much nitrogen your crop needs to achieve its yield potential. A nitrogen balance is looking over the long term to see how your farming system is tracking in terms of whether it's running down its total soil nitrogen or building up or maintaining. And that's a good way of checking what your soil organic matter is likely to be doing. And we've also made a example spreadsheet for that, which you can plug your own numbers into. And then we've got plenty of time for discussion and conclusions. And I'm certainly happy if anyone's got a question or wants to raise their hand while I'm talking, for you to do so at any time. Right, so starting briefly with the background stuff, soil organic matter, which we'll often abbreviate to SOM. Essentially, it's plant matter and microorganisms in various states of decay within your soil. And there's different fractions of it. So there's, the general term is soil organic matter, but then there's different bits of it. There's some bits that are just plant matter, like light particulate matter, and there's other parts that are more dead microorganisms like humus. But when we're talking about soil organic matter, mostly we're referring to humus, and it's the most stable and important fraction from an agricultural perspective. And that's not, you can't see it in your soil. It's not little bits of plant like you see on the paddock surface. It's generally small and locked up and stuck between soil particles. And that's one of the important roles that it plays in your crop production system, is that it's the glue that sticks soil particles together so that soil has structure. So it's little lumps of soil, aggregates stuck together, rather than just a matrix of soil particles. And if soil's got structure, that means it's got pore spaces within it, and that lets air and water and roots move through soil more easily and lets roots obtain those resources. So it's important from that perspective for giving soil structure. But its most important role in a crop production system is it's a bank of crop nutrients, and particularly nitrogen. And nitrogen cycles in and out of soil organic matter. And it's an important source of nitrogen for your crops. But as we'll talk about, it needs to be looked after and maintained. And so from a crop production perspective, there was a paper published by some Danish authors recently that clearly showed that the most important role that soil organic matter plays in crop production systems is provision of nitrogen through mineralisation. Okay, so this bit's about understanding the relationship between soil organic matter and soil organic carbon and soil organic nitrogen. So the really important thing that we need to remember is that soil organic matter, which is the stuff we're interested in, is a fixed and pretty constant ratio of carbon and nitrogen. And it's about 12 parts carbon to 1 part nitrogen. And it has to stay in that ratio. If you deprive the microbes that form soil organic matter, that comprise soil organic matter of one of those nutrients, then soil organic matter declines, because you need both of them in their correct ratios in order to build it. It's also comprised of other nutrients as well. So Clive Kirkby showed that phosphorus and sulfur were also in constant ratios. But in cropping systems, nitrogen tends to be the most limiting nutrient for the formation of soil organic matter, because it's also the nutrient that our crops use in the largest amount, and the amount that we export the most out the farm gate in terms of grain. So every time we're sending a ton of wheat grain out of the paddock, we're sending off 20 kilograms of nitrogen or thereabouts. So that's why it's an issue. Now, soil organic matter itself is hard to measure in a laboratory. It's hard to come up with a percentage content or an amount. And that's why we tend to talk about soil organic carbon, because there's good laboratory techniques for accurately measuring soil organic carbon. So really the only reason we're interested in measuring carbon from a production perspective is because it's easier to do. So we're just measuring it as a surrogate for soil organic matter. Obviously, in terms of carbon sequestration and accounting and that sort of thing, measuring the ability to measure carbon is important. But if we're just talking purely about crop production and agronomy, we're only measuring soil organic carbon because it gives us an idea of how much soil organic matter is in there. And really, the carbon isn't that important. Plants don't care about carbon. They can fix their own carbon. What they need is nitrogen. And that's what's most important to crops. Does anyone got any questions or need anything clarified there? Nope. So the nitrogen in your soil is divided into two parts. So we have mineral nitrogen, which we largely measure. Well, the bits that are important for crops are nitrate, or NO3, and ammonium, NH4. And they're readily available for uptake by both plants and microorganisms. And they're what we measure in our deep end soil tests. So they tend to be present in tens of kilograms, sometimes hundreds of kilograms, if we're lucky, of nitrogen per hectare. And an analogy or a way of thinking about this is that's your nitrogen cache. It has high liquidity. Your crops can use it, but it can also be stolen easily by microorganisms, or it can be leached or denitrified or lost from your system. Then we have organic nitrogen, which is where most of the nitrogen in your soil sits, locked up in soil organic matter in that constant ratio, 12:1 with carbon. And usually there's thousands of kilograms per hectare of nitrogen stored in soil organic matter. But the issue is that it's not available to plants. And a way of thinking about this is your nitrogen shares, your investment. So it's got low liquidity, but it's a large amount of wealth, and it pays a cash dividend every year in terms of mineralization. But it also requires a management fee every year, which is immobilization. So your microorganisms immobilizing nitrogen is the cost of maintaining that.
James, just a quick question from Brad. What are the ratios of phosphorus and sulfur with organic matter?
I can't remember off the top of my head. They're much lower than nitrogen, but I'll look up Clive's paper for you, and yeah, I'll post that. I'll do that bit of research maybe while you're talking, Kate, and put that in the chat. So this diagram basically describes how crop production and soil nitrogen work. You've got your total soil nitrogen here, which is comprised of its organic component and your mineral component, and nitrogen cycles between these two pools, comes out of organic N through mineralization and back in through immobilization. So these are your shares. These are the cash in your nitrogen wallet. And then we have inputs and outputs from this pool. So our inputs, our number one input in cropping systems, particularly continuous cropping systems, is nitrogen fertilizer. But you can also get it from manures and composts and biosolids and other organic materials that contain large amounts of nitrogen. We can also get it through rhizobial nitrogen fixation. So that's when legumes fix atmospheric nitrogen. And you get a little bit imported in rainwater and dust that lands in your paddock. And there's also a small amount fixed by free living organisms that, so they're organisms that fix atmospheric nitrogen, but they're not associated with plants, as in rhizobia. They live freely in the soil, and they fix a small amount. The outputs, the biggie in cropping systems, particularly in the Wimmera Mallee, is exporting grain. So that's where we lose the most of our nitrogen, is what we send out the farm gate. So if you've got a 7 tonne per hectare wheat crop, which sometimes you jag in the Wimmera and Southern Mallee, you're sending out 140 kilograms per hectare of nitrogen. You'll also lose it if you're burning or baling stubble and sending that out the paddock, or hay, obviously, as well. And there are losses to the environment, so denitrification, leaching, volatilisation and runoff. These tend to be pretty low in low to medium rainfall zones that have a decent soil, with a reasonable plant available water capacity. So it's pretty rare to lose nitrogen through these mechanisms in the Wimmera and the Mallee. Denitrification becomes a much bigger issue once you move to southwest Victoria, for instance, and you're having soil waterlogged for a long period of time. So they're our inputs and outputs from the system. Now, the issue with crop production, particularly continuous crop production without lay pastures in there, is that soil mining is pretty common. And so that is essentially just when the outputs exceed the inputs. So you're taking off more nitrogen in grain than you're putting back with fertiliser or legumes. And that's been pretty common right throughout history and right throughout the world. And so what happens if you're exporting more than you're putting in is that nitrogen that mineralises out of your total, of your organic N, gets taken up by the plant and then exported as grain. So it's on a one-way journey. It mineralises out of the organic pool, gets taken up by a plant and shipped out of the paddock, and that sort of keeps happening and there isn't any, well, there's little top up. So the issue is that if you're removing nitrogen, you're running down your total soil organic nitrogen, then soil organic matter runs down as a result because you can't maintain that ratio of carbon to nitrogen. So you also run down your soil organic carbon because they're in a fixed ratio. So if you pull one down, then the other one comes down with it. And so that's why it's called mining your soil organic matter. Does that make sense to everyone? Yep. So is this a bad thing? It's still a bit moot point whether it is bad or not, but the evidence we have to date is that it's probably not good from a production perspective. So what happens as soil organic matter declines over time is that the levels of mineral nitrogen prior to sowing start to decrease because you're not having so much mineralisation during the summer fallow period. Your levels of in-crop mineralisation also decrease. So crop production becomes really reliant on fertiliser nitrogen, and reliance basically increases on fertiliser nitrogen. So to achieve your yield potential in a given season, you have to be really sharp with your nitrogen management and gung-ho with your nitrogen rates in order to achieve those yield potential. And the issue is that often it's pretty hard, for various reasons, to respond with fertiliser in favourable years. It can get too wet, it can rain too late in the season. The situation we had last year that Kate's going to talk about more is that we had quite a lot of water stored in the soil profile and the yield potential was quite high, but the topsoil dried out, so fertiliser, the crop couldn't take up fertiliser nitrogen. So these sorts of situations are pretty common. And so what happens is you start to get yield gaps in higher yielding years because you just can't respond with nitrogen fertiliser. It also becomes quite risky because you have to invest a lot in nitrogen fertiliser. You've got a large value at risk in cost of nitrogen fertiliser in order to achieve yield potential. And I guess the reason why we're starting to talk a lot more about nitrogen is that nitrogen deficiency is already the #1 reason for the gap that exists between farm yields and water limited potential yields in Australia. So it's the #1 reason why we're not getting the yields and the water use efficiency that we should be getting, and we don't really want that to get worse for profitability and food security reasons. So I'm going to hand over to Kate at that point, and she's going to talk about a specific illustration of why having low soil nitrogen, so low mineralisation and low mineral nitrogen at the start of the season is an issue. Do you want me to hand control over to you, Kate, or?
I think the best way will probably be if you keep sharing your screen and I'll just say next slide. How's that sound?
Sounds good.
So next slide, please. So this is some trial results that BCG ran last year at the Birchip main site at Karari. And for anyone who visited the field day or was at the site last year, we had the site split across 2 paddocks. We had a west site and an east site. So that was handy for herbicide residues, but it also meant that we had 2 paddocks that were pretty similar soil type, had the same amount of rain, but also had very different starting soil nitrogens. So in April, when we did the soil tests, we found that, these slides are the wrong way around, I'm sorry, but the high end site had 80 kilos of nitrogen per hectare, and that was from 0 to 100. And then the low end site had 20 kilos of nitrogen per hectare, or 20 units of nitrogen per hectare.
So these numbers should be swapped around.
Yeah,
Yep.
yeah. So we also had pretty similar starting soil moistures, but slightly different crop rotations. But the main key point is that we had 2 pretty similar paddocks that had quite different starting soil nitrogen. So what we did in this trial was we designed it, and then we sowed both sites on the same day to Septa wheat on the 16th of May. And then we spread both sites at the same time, GS30, so just after it had finished tillering, on the 25th of July, prior to what ended up being quite a dry spring. So after we spread, we did get 10 or so mils to wash it in. But as we all know, last year the tap turned off and things got a bit tight towards the end. So I won't go too much into the trial, I'll just show you the results that we found. Can I have the next slide, please? So if you have a look, the blue triangles, that's the low site that only had 20 units of N, and the orange circles, that's on the high end site that had the 80 units of nitrogen already stored in the soil. And then across the bottom axis is how much nitrogen we applied. So that was in the form of urea at GS30. And as you can see, we were getting a long way up there in the rates. And what we saw was that on the high end site where we had 80 units of nitrogen already in the soil, we didn't see a significant yield response, no matter whether we put 0 units out or we put close to 200 units out. And the main reason for that was with that dry finish last year, we got enough rain to wash it into probably the top 10 or the top 20 centimetres of soil. However, when that dried out come the spring, the crop couldn't access that as well as it could. On the low end site, we did see a yield response, but as you can see, the yields were probably a fair way below 3 tonnes or under 4 tonnes for a couple of treatments there. That's probably considerably less than what you would have been after last year. In Birchip, it was a pretty good year. It was a chance to grow a lot of grain. So we did see a response on the low end site where yield increased as we increased nitrogen. So that was handy to see. So what it's trying to say here is that, and it's also worth noting that on the high, we didn't have a single treatment on the low end site that yielded better than any of the treatments on the high end site. So it didn't matter how much we threw at the low end site, we couldn't get it up to the same yields as the paddock that had 80 units of starting in. Next slide, please. However, despite the fact on the high end site, you might say, okay, look, you didn't see a yield response. Why would you bother spreading urea if I've already got high starting soil in? And I do agree there are some risks involved with that, but what you'll notice is that the grain proteins here were incredibly low. We didn't have a treatment that went better than ASW last year. Everything fell under that magical 10.5% protein. So that is a significant decrease in pay grade. What we did see on both sides, both high side and the low side, was that with increasing nitrogen rates, we did manage to increase grain protein. And the fact that we had some seriously low grain protein showed how nitrogen deficient the crop was. So what this trial aimed to show, and I think shows quite well, is the impact of having a low starting N can have in a season where you haven't got the chance to get urea out. So where it was high, it did all right, but where it was low, we put urea out dry spring and the crop didn't get the nitrogen it simply needed to increase its yield or to have an acceptable deliverable level of protein. The other reason that I like to emphasize these trial results is that it highlights quite nicely the importance of knowing your starting soil nitrogen. You might have a very different urea, a very different nitrogen plan on the high site compared to the low site, or if in a year such as this year, when there's not much rain on the forecast over the next couple of weeks, how do you decide which paddock gets spread first? So I personally would spread that low end site first because it's going to need it a lot more than the high end site. And it also allows you in a year where the budgets are a little bit tight to prioritise which paddocks will get the nitrogen and which paddocks won't. Next slide, please, James. But unfortunately, as James pointed out before, we don't know which strategy is the most profitable in the long term. Obviously, mining your soil nitrogen, if you're not putting urea out, well, the gross margins are going to look better than if you had potentially, if you don't see that return in yield. So that's for another trial that BCG is currently doing at the moment, working with LaTrobe University, and it's being funded by the Mallee CMA. And this is a long-term site that we've got set up at Currio. We've got 2 years worth of data already from 2018 and 2019, and this trial will be ongoing for another 4 years at least. Looking at should we be aiming to maintain a certain level of soil nitrogen in the soil every year, or should we be trying to match nitrogen applications to seasonal potential? If it's a wet year, should we put more out compared to a dry year, we put none out, or are we better off just applying an average every year regardless of how much the crop's expected to grow? Next, please. So as I was saying, there's two main strategies in this trial. There's the nitrogen bank strategy, which is where we aim that there will be a certain number of units of N available to the crop every year. And the other strategy is using yield profit to try and match the yield potential to the amount of nitrogen we put out. And to do this, we soil test every autumn, and then we top dress it as urea in sort of June, July, August, depending on rainfall fronts and growth stages. Next slide, please. So this is just to quickly explain how we used yield profit to match nitrogen applications to seasonal yield potential. So if you look at the bottom one, which is sitting at a 25% probability, so that's 25% chance of achieving that decile of rainfall. So the green line is nitrogen limited, so that's if we solely relied on the amount of nitrogen in the soil. And the blue line is the water limited yield, so that's if we applied enough nitrogen to 10 out of 10, the crop's got all the nitrogen it needs. It's not limited by nitrogen. The only thing stopping this crop from growing is how much rain that falls from the sky. So when we look at, 25%, that's a decile 8 year. So if we don't apply any nitrogen, we can only grow 1.8 tonnes. But if we are prepared to top dress it to meet yield potential, we could potentially grow 3.2 tonnes. So that's what we call the yield gap when it comes to nitrogen, the difference between what we could grow without applying nitrogen and what we could grow if we gave it all the nitrogen it needed. So in a decile 8 year in 2018, which obviously we didn't get a decile 8 year in 2018, we had a 1.4 tonne gap, and then you work that out to how much, to meet that 1.4 tonne gap, how much urea do I need to put out? Using the rule of thumb of 40 units of N per 1 tonne of grain at 11% protein, we apply 56 kilograms of N. Next slide, please. So unsurprisingly in 2018, it was a dry spring, a dry winter, and a dry autumn generally. So we only received 8 mil in the month and a half following application. So which meant it was washed in, but there wasn't any way that that crop could access the nitrogen. And as a result, we didn't see any significant differences in grain protein or grain yield. And we saw that basically the best performing gross margin was one in which you applied no urea because it just lessened your costs. Next slide. However, it's worth noting that, so we measured the starting soil N before cropping in 2019, keeping in mind that Birchup received 200 mils of rainfall in December of 2018. And what we found that for every 1 kilogram of nitrogen or 1.46 kilograms of urea that was top dressed in 2018, there was 0.6 of a kilo of N available to the crop coming into the 2019 season. So it showed that what we applied, we didn't lose it in 2018 when the crop didn't access it. It was still there for us in 2019. Next slide, please. So 2019, we had a pretty handy canola crop on this trial out at Currio, and we top dressed it at the 6 leaf stage, and again it received rain afterwards to wash it in. And what we began to see was that there are differences in yield and in grain oil in the canola depending on how much nitrogen applied. So the highest yielding treatments were the nitrogen banks, where we ensured that the crop had access to 100 units or 125 units of N every year, and the 75% yield profit, or the decile 7-8 yield profit, which was quite generous given the season that we ended up receiving. Next slide. So when you combine the 2 years of data and you start looking at gross margins, because realistically that's a pretty important factor at the end of the day, we've seen that the gross margins are maximised somewhere in the middle there. If you don't apply enough nitrogen, you don't get the yield. If you apply too much nitrogen, you can either decrease your yield and you see the increased cost in having to apply extra urea. Next. And what we also saw in terms of nitrogen use efficiency, so that's how much of a yield increase do you see as a result of applying N. We again are seeing that's maximised at around 50 to 60 kilograms of N per acre, per hectare, sorry, to speak in the old language, falling again in the middle. And that's the end of my presentation, but I'm sure James and Harm have got some comments on this trial as well.
No comment from me unless there's questions from people.
No, I haven't. No comment from me either at this stage.
All good. I'll pass back to James then.
Okay, so that was a very good summary from Kate of research that BCG and LaTrobe are trying to do to untangle these issues and work out what is the best in terms of profitability over the long term. But I just thought I'd give a little description about building soil organic matter in cropping systems and how you can do that with nitrogen, because it gets talked about often like it's an easy thing to do. It is possible, but it's not easy, and it's not easy to do quickly, and it's not easy to measure in the short term. So you can build soil organic matter in continuous cropping systems, but you need a source of carbon. So you need to retain crop residues because that's your main source of carbon. You need a source of nitrogen that exceeds basically so you're adding more nitrogen than you're taking away in grain production. So you need to have a positive nitrogen balance. So that doesn't really matter where it comes from, legume, fertilizer, manure, it just needs to be there. And you need to make sure that other nutrients, phosphorus and sulfur, and thank you very much for the person who found the ratio not limiting. And different soils differ in their ability to be able to store soil organic matter as well. And you need sufficient habitat, for want of a better word, for places where the soil organic matter can be locked up, live, and not be oxidized. So that keeps it safe. And yeah, it takes a really long time to measure even small differences. And there are other studies done around the world that have looked at this. The best one, or the one that's most relevant, I think, to the Wimmera Mallee was actually done in China, but it was from a dryland, semi-arid part of China, so up on the Lurs Plateau. So reasonably low rainfall, much harder winters than we have, but wheat-dominated production system. So there was an experiment that was published in this paper here that looked at different levels of nitrogen inputs over 25 years, which is sort of the length of time that you need to be able to measure these differences. And these are the results they got in terms of biomass and yield. So these are the different nitrogen rates down here that they applied for 25 years, every year for 25 years, either 0, 45, 90, 135 or 180 kilograms of nitrogen. So sort of similar to what we're doing at Curio, but we're coming about it a slightly different way. And this is the yield. So yeah, looking at this, I've kind of nominated this point here as the most profitable. These are the means over the 25-year period, but Harm previously pointed out that this one's probably about equally or possibly slightly more profitable. But anyway, remember those two rates, the 90 to 135 kilograms per hectare of nitrogen at a yield of about 4 tonnes, so or a bit below 4 tonnes, which is not out of, yeah, pretty similar to the Southern Mallee and Northern Wimmera. This is what happened to the soil organic carbon under those different nitrogen scenarios, measured to 0.2 of a metre depth over 25 years. So in the 0N treatment, they were nitrogen mining ever so slightly, so about 20 kilograms of nitrogen going out the gate a year, and there was no change in soil organic carbon. Soil organic matter was, well, soil organic carbon that they're measuring here, so it was pretty flat. There was a small positive N balance with the 45 kilos of N, about 5 kilograms per hectare per year, and you got a small, very small increase in soil organic carbon. This one here we're arguing is the most profitable, and if it's not that one, it's probably this one, was running a positive nitrogen balance of about 30 kilograms per hectare per year, and soil organic carbon increased. And yeah, to me that's interesting that the most profitable treatment is the one that's actually building soil organic carbon and is running a positive nitrogen balance, as opposed to ones that are mining. So we're going to have to wait 25 years for Curio to deliver the same results, but yeah, it'll be interesting to see if they are the same. So the take-home message that I hope you all appreciate is that soil organic matter provides you with your crop with an important source of N that is different in the way it's made available to the crop than fertiliser N. And having that resource there is a positive thing for crop production for various reasons. And we need to look after it. So it needs to be maintained with inputs of nitrogen. You need to pay that immobilisation fee, or the microorganism tax, as we refer to it sometimes. And so effectively, you're really fertilising 2 crops in your cropping system. You've got your above ground grain or hay crop, which you're trying to supply with enough nitrogen for it to reach its yield potential in any given year. And then you've got another crop under the soil, which is your soil organic matter that you're trying to maintain at a constant level, or perhaps even build to give you that resource to mineralise nitrogen when your crop needs it. So I put this photo in it here because it's kind of got both of those crops in it. We've got our canola in the background here and our urea prills here, and in here there's hidden microorganisms that are using this carbon from the stubble as a food source, and they need the nitrogen to grow. And once they die, they'll form humus, and they'll have that constant ratio of carbon and nitrogen in that. So they're the two things that we're going to cover in this workshop: feeding the above ground crop, and Harm's going to talk about nitrogen budgeting now, and then we'll talk about how we make sure that the below ground crop has enough nitrogen in the long term, and we'll talk about calculating a nitrogen balance. So at this stage, I'll hand over to Harm. Harm, do you want me to give you control?
No, why don't you do it, James? Is that all right?
Yeah, that's fine if you're happy.
Okay. So that's a really good background from both Kate and James. And now we're going to talk about this year, because there's some huge opportunities for this year. So James, next slide. So we have a look at what's happening thus far in the Southern Mallee, and I'm sure a lot of areas are very similar north of the divide. So summer rain, November last year to March this year, 183 mil. Growing season rainfall to date in Birchip is a decile 9 season, so 1 in 10 wettest years. Now, if we, just a couple of little guidelines, you can make this really complicated, or you can also use some fairly simplistic equations, but they usually work out reasonably well. So roughly 25% or a quarter of summer rainfall. So that's the rainfall from November to March, November last year to March this year, is available to this year's crop as stored water. And that's from that 183, a quarter of that is 46 mil. So that is plant available water stored in the soil, assuming that there were no weeds, because obviously if you've got summer weeds, then it's likely to be none. So if the paddock was full of heliotrope, then you're unlikely to have any water left, and there'll be lots of nitrogen taken out as well. So it's a hugely optimistic start to the season. James? So it's really critical to get your end application right this year to grow a 10-tonne crop. This picture of a 10-tonne crop, which I'd love to see in Birchip. I've seen 6 to 6.5 tonne wheat crops, but I've never seen more than a 6.5, and even that is a fantastic achievement. So next one, James. So we have to get, the most important thing is you can put out a lot of nitrogen, but if we've got diseases and weeds, then obviously you're not going to get the right crops. So disease management is a given, and weed management is a given. And we have to sow our crops on time. Now, James and lots of other people have shown the importance of that in lots of trials at the BCG, where late sowing crops, they end up with low yield potential. So, and it is a really difficult thing, is to try and get your crops flowering and maturing without frost or without heat shock, so in that magic window. And unfortunately, that window is quite spread out, so it is not always possible. But through experience and using the data provided by the BCG and others, there's lots of good information of what is that window that your crops should be flowering to maximise its yield potential. So if we're going to do a simple nitrogen budget for this year, we know that every tonne of wheat, we need 40 kilograms of N, and that 40 kilograms can come either out of the soil profile or the urea or other nitrogen sources that you are applying this year. Next one, James. So starting soil N, as in that example, north of Birchip, was 155 kilograms of N, and that was actually on a cereal hay crop, so a lot of mineralisation with that large amount of rain from last year. And starting available soil water, so that is available stored water, was 45 millimetres as calculated. And Skepta wheat was sown on May the 12th. The current growth stage is 3 leaf. And, well, that's just giving you where we're up to. So, in 155 kilograms of N, plus the N that was applied at sowing, just in the MAP, is more than enough to get the crop to growth stage 16, which is when we've got to start thinking about applying more N. But there's definitely no urgency of applying N in the next few weeks. Next one, James. So this is just presented graphically what would happen in different rainfall starts. So different rainfall outcomes for the rest of the season. So the beginning of that green line is June the 1st. So that's when I did the measurements. And assuming the same kind of finish that we are in currently, a decile 8 or a decile 9 finish, that's the far end of the green line, we should be producing well over 6 tonne of wheat crop, just up there. So that is if the season continues the same as it is now. If it's drying out, so halfway along that line, James, this would be a decile 5. So we'd be looking at a 4 to 4.5 tonne wheat crop. And if we finish on the decile 2, then we'll be growing a 2.5 tonne wheat crop. So that's how you can start budgeting how much nitrogen you need to put out. Because if you've got a reasonably good idea of where we are today and where we're likely to finish up at the end, then you can do your nitrogen budget. And the amount of rainfall, whether we're going to finish on a decile 5 or a decile 8, we're never going to know until it's actually happened. But with the current forecast from the Bureau, the IOD, and being positive, and a lot of positive other indicators, is that it's likely to be a wetter than drier finish. And remember that you don't, for this particular paddock, you don't really have to do anything until growth stage 16. So there's still quite a few weeks where there's no urgency to be applying more N. Next one, James.
What does growth stage 16 look like if you're looking at it out in a crop and you haven't got your trusty growth stage guide beside you?
Okay, so it's 6 leaves. So you pick a plant, you make sure you pick out all the tillers, and the tillers are growing out of where the main leaves are. And once you've removed the tillers, you count the number of leaves, and that is the 6th leaf. Now, if you waited another couple of weeks, you'd be at growth stage 30, so then you start feeling the first node right at the base of the plant. So whether you're at growth stage 16 or 30 is a very good time for putting out nitrogen on this particular crop, because it doesn't need any until that time. So growth stage 16, 6 leaf, and there's so many guides available on counting the Zadok scale or the decimal growth stage scale that you should be able to download one, and that makes it quite simple.
And Scepter gets to growth stage 30 at about 6.5 leaves. So yeah, if you've got 6 leaves, you're about, as Harm says, you're a week or 2 away in winter temperatures from going stage 30.
Next one, James. Okay, so here I've made a simple table of how much nitrogen is required to grow the crops that we had a look at on that little graph before. So in a rainfall decile finish from June the 1st, so decile 2, so that's a 2 in 10 driest years. We expect another 74 mil of rain between now and the end of the year. Then your water limited yield, so that's nitrogen unlimited, is 2.8 tonne. And generally, we look at an economic yield potential to take out some of the risk. So that's 2.2, so that's taking 20% off. And the total amount of N required to achieve that yield is 90 kilograms per hectare. So that's the total N. And then we'll have a look at, in a minute, what that actually means for this year. Decile 5, so that's average rainfall. We'd expect another 129 mil of rain for the rest of the season. The water limited yield is 4 tonne. The economic potential yield is 3.2, taking that risk factor into account. And we need 128. And if we do end up with a wet finish, we need a total of 216 kilograms of N. Next one, James. So if you take into account how much was actually in the soil at planting, which was 155 kilograms, so we're doing exactly the same calculation, then you won't need any more N in the paddock in a decile 2 or a decile 5 finish. But when we are getting later in the season and the season starts looking like it's going to have a decile 8 finish, then we'll definitely need more N, and which is a total of 61 or roughly 130 kilograms of urea. And the growth stages, James, I think that's on the next one. So the growth stages where you have to do that, that's the third point. So as I said before, growth stage 16 and to growth stage 30, which we'd expect from current conditions and the day it was sown and this year's temperature, we would expect that to be on July the 8th. And the next opportunity for the second amount of application of N, so you treat the N application to 61 kilograms of 66 kilograms of urea each at growth stage 16 or 30 to growth stage 30 and growth stage 37. And we expect that around August 25. Now that's obviously a trickier one in relation to making sure that you put out that nitrogen before a significant rainfall event to wash that N into the soil. Because James pointed out before that if you have a dry finish and most of the nitrogen which has been applied is in the topsoil, then the plant roots don't necessarily have access to it. So rain is essential after application, and that's another risk factor. It's a much lower risk factor at growth stage 16, which is early July when things are still cool, but much higher in the towards the end of August. Next one, James. So just a few assumptions that we've had a look at in terms of doing our N budgeting. So if the crop is using nitrogen from soil mineralization, as pointed out before by both James and Kate, you run the risk of running soil organic matter. So you have to balance the amount of nitrogen that you put out in relation to what you expect to be growing. So we need 40 kilograms of N per tonne of production, which is, as James pointed out, about double the amount of N that's taken off in the tonne of grain. That's an inefficiency factor there. You have to know your starting soil N, because if you don't know what you're starting with, I guess you'll be guessing throughout the whole of the season. And a lot of people use estimates based on previous crop type. I'm not totally convinced that is always a good thing to do, because growing a legume, there's obviously a higher nitrogen there, but it could also still be in the organic form rather than in the inorganic form, which is available to crops. And this particular example I showed you, like I said, it was on a cereal hay crop, and there was still 150 kilograms of available N measured in the paddock, so which is significant. If the soil has significant subsoil limitations, such as high acidicity or high boron levels or extreme alkalinity, then that will reduce root growth, and which will restrict the amount of yield. So understanding the potential of your soils is also important. Waterlogging will reduce, well, it will improve denitrification, will increase denitrification, so we're going to lose more N. And you can also get deep drainage, so you're actually losing nitrogen. It's always important to try and make sure the urea goes out before rainfall. And like I said right at the beginning, if there's a frost or a heat shock at a new flowering, that is definitely going to affect our potential yield. So it's never going to be risk of it's never going to be without risk applying extra N out in crop, but doing these fairly simple bucket applications or calculations and then applying the N according how the season is actually developing is a really good management practice. And James, one more. And we always got, as a backup, have yield profit available to us. And there's been so much work done now and with yield profit and as a guide, and some people actually have a lot of paddocks in yield profit, so they're using it more as a guide. But as a good guide for the season and how it's developing and what the risk factors are, I think it's a fantastic idea to have 1 or 2 paddocks in yield profit and base your nitrogen management risk factors based on those couple of paddocks and what's actually happening out in the field in terms of denitrification and nitrification and how much N you should be applying, what the weather risks actually are in relation to the current signals. And so some people use it on a per paddock basis to make their decisions, but others are using it as a guide to what's actually happening on the farm in relation to overall risk management. So I couldn't recommend it more. Next one, James, and I think it's back over to you.
Thanks, Harm. So the idea is that we just have a look through the spreadsheet, which I'm sure many of you probably have a similar spreadsheet that you may use, but for those of you that don't, yeah, this could be a useful resource. So I've just got to have a quick techno wrangle and share a different screen. Bear with me, folks. Can everyone see a spreadsheet?
Yes, James.
Fantastic. So this is just a pretty simple spreadsheet that Kate and I put together for this.
You might have to make it a bit bigger though, James.
Okay. How's that? Is that better, Harm?
You know, that's good, James.
Cool. So the way it's set up is that there's orange columns, which is where you can enter information, and then there's white columns, which is where it outputs information. So it's set up, this is the budgeting part of it. It's set up to do, it's set up to do paddock by paddock essentially, or zone by zone. So we have a column for paddock, a column for species, a column for November to March rainfall. So remember Harm talked about how you can estimate how much starting soil water you have by taking 25% of summer fallow rainfall. It's a rough rule of thumb, but better than nothing at all. Oh, by the way, if you need sort of help or a bit of a guide of what all these things are, you hover your mouse over the purple triangle up here, it'll give you a bit of a explainer. So you enter the your November to March rainfall, you enter the rain from the 1st of April to the date which you want to use the spreadsheet, so the date you're making the decision. And then this is the crystal ball gazing bit, and the bit where yield profit is really useful. You need to have a think about how much rain you're likely to receive for the rest of the season. So I've entered in 120 millimetres, which is similar, I think, to about a decile 5 season finish for the Southern Mallee. So then the spreadsheet will use that to calculate your total crop water supply, which is your in-crop or growing season rainfall, these two columns here, added together, plus 25% of your November to March rainfall. It then uses your crop water supply to estimate a water-limited potential yield. And for wheat, it's based on the Sadras and Angus water use efficiency relationship, which is the one that Harm put up the example of before. So it's subtract 60 millimetres from your total water supply and then multiply by 22 to come up with the water limited yield potential. For barley, I think I've used 25, I've done this in tonnes per hectare, so it's taking the information from this table over here, the green table over on the right. So barley, it's assuming a transpiration efficiency of per grain of 25 kilograms per hectare per millimetre, and for canola, it's 12. And so it uses these to calculate a water limited potential yield. As Haram mentioned before, it then gives you an estimated economic yield, which is 80% of estimated water limited potential yield, to reflect the law of decreasing returns, and it's not necessarily economic to pursue that last 20%. And based on that, it calculates a total crop end demand, just based on the rule of thumb for wheat, the 40 kilograms per hectare, the 40 kilograms of nitrogen per tonne of grain, 35 for barley, and 80 for canola. So it's all rough rules of thumb, but it's doing something is better than doing nothing. And so that gives you the total crop end demand. Then you enter your starting soil mineral nitrogen from your deep soil N test, and you have to enter it in kilograms of N per hectare, but Kate has put a very cool table over here where if you just nominate your depths and your soil type, and she's put a little menu in so you can choose your soil type, it will estimate your bulk density. And then you just put in your nitrate and ammonium off your soil test in milligrams per kilogram. So a lot of soil tests just come back as milligrams per kilogram rather than kilograms per hectare. Then it will calculate your mineral nitrogen in kilograms per hectare and total it there for you. So you can put that number in over here to get going with the calculation. Then you put any previous fertiliser application, so any nitrogen that you applied at sowing or pre-drilled or top dressed early, etc. And then it tells you how much fertiliser nitrogen you need to make up the balance of the crop nitrogen supply. So that's how much fertiliser you need in order to achieve economic yield, and then it just expresses it in kilograms per hectare of urea. So if we look at paddock 1, which is wheat, we've said we've had 120 of November to March rainfall, 120 of 1 April to now rainfall, and we're guessing that we're going to get 120 for the rest of it. 270 millimetres of total crop water supply. So our estimated economic yield, the yield we're targeting, is 3.7 tonnes per hectare. Our crop end demand is 148 kilograms per hectare. We have this much in the soil at sowing, prior to sowing. We've added this in our MAP, 5 kilograms per hectare. So we need 70 kilograms of fertiliser nitrogen to achieve that economic yield, which is 152 kilograms per hectare of urea. So it's fairly cheap and cheerful, but hopefully simple and effective. Does anyone have any questions on that one?
So James, have you got a rule of thumb on how much nitrogen to apply as a single dose in the Southern Mallee Wimmera, depending on the time of year?
As in too much or too little?
Yeah.
It's questionable whether it's worth applying any less than 20 or 30 kilograms per hectare, and I think you can comfortably apply easily up to 100 kilograms of nitrogen, so over 200 kilograms of urea in, as long as you're top dressing in July, which is really the premium top dressing month because it's the coldest month. You've got a bit of crop cover. You're pretty unlucky not to get showers throughout July. Your chances of losses are pretty low. So that's really the yeah, and your crop's usually around 6 leaf or Z30, so that's really the month to get the nitrogen into the crop in the Southern Mallee, I reckon. And yeah, you can certainly top dress it at flag leaf, as you said, but you're just exposed to more risk of not getting a follow-up rain. There's one question on the chat. Let me check that. Cool. Any other questions on that sheet?
Yeah, James, it looks like we haven't got any hands up at the moment.
Kate, did you have your hand up? Sorry, scratch that.
Okay, I'll just have to get back to the...
James,
Yes.
so say for a canola crop at the moment, do you think it's actually a bit too early yet to be applying urea?
No, canolas. So the reason why we tend to wait until after the start of stem elongation at the end of tillering for wheat is so we don't hay the crop off, so create too many tillers. But that doesn't really happen in canola. It's far less sensitive to when you apply the nitrogen. So yeah, it's fine to go now.
Yep, fair enough.
James, there's a question in the chat box. Can you suggest a foliar limit for N?
Foliar,
Yes.
as in applied liquid. That's kind of dependent on a lot of factors to do with weather and what sort of nozzles you're using and that sort of thing. My only experience of doing that comes from 2013 with Southern Farming Systems, where they had massive yield potential, 10 tonnes per hectare plus, and we were putting out, I think we were putting about 130 kilograms of nitrogen as UAN through streaming nozzles, and we scorched the crop. So don't put that much out. But yeah, it's the earlier you do it, the lower the risk, and streaming nozzles are obviously less risky than your regular nozzles. So yeah, those sorts of things reduce your risk factors, and then you're obviously limited in how much product you can squirt out through a boom anyway. But yeah, if you're doing it at a cooler part of the year when the crop's less likely to be water stressed and there's more likely to be follow-up rainfall, the risk is lower. Is that a helpful answer?
Looks like it. Brad Plant's got a question for you, James.
Yeah, James, any difference for barley versus wheat in terms of timing?
You can go earlier in barley, or barley is more sensitive to nitrogen stress earlier in its life cycle than wheat is. So it can't compensate with the number of grains it sets per spikelet on the head, because it's only 2 row, right? We only grow 2 row barley. So yeah, you need to be a bit more careful about not reducing your tiller number in barley with nitrogen stress. But it's pretty plastic, and it's pretty hard to overcook Spartacus types of barley. Yeah, so they're far less sensitive to having a lot of nitrogen up front than say something like Compass, which is likely to lodge and fall over. So yeah, it's less risky to top dress barley earlier than it is wheat, I guess is what I'm trying to say.
Yep. No, thank you.
So James, there's still farmers out there that are applying liquid N as they are putting their herbicides out, and that's another strategy that some people are using. So some are using UAN and others are using just liquid urea, making their own mix. And as long as the rates are not too high, then that's another strategy of feeding your crop as it's growing, I guess.
Yeah, I guess you'd probably be limited to about 20 kilograms per hectare or less of nitrogen.
That's right. Yep.
And your chances of scorching are probably a bit higher once you start mixing with herbicides and oils and things.
If there aren't any more questions, we might move on, James. Is that the plan?
Yeah, definitely. I just got to...
There's one more there from Cam who probably can't put his microphone on because he's bouncing around in a spreader.
From 30 to... Right, so Cam's saying he's got, on Wimmera clays, seeing a gap in the moisture from 30 to 70 centimetres. So I guess that means he's got a gap of dry soil. They'll still need good winter rain to meet potential. What strategy do you use in this situation? I guess you kind of have to assume that water below 70 centimetres isn't going to be available in low decile years. So it's kind of double or nothing. In a low decile year, those two bands of water won't meet up and the deep water won't become available. So you shouldn't include it in your calculation of potential yield. But if you start to get decile 5 or above, then the two lots of water do meet up, and then you get, it becomes available. So you've got real extremes in yield outcomes from either a dry season or a wet season, because you're getting that extra stored soil water become available.
So should Cam do his budget on 30 centimetres then?
Cam needs to decide whether he's lucky punk and whether he's going to get a decile 2 or a decile 8 season. And only Cam can make that decision. Okay, I'll just go back to the presentation. Okay, we've done that. So we're into the nitrogen balance, which is about feeding or ensuring that your below ground crop has enough nitrogen in the long term. So the reason why we bother to do this is because it gives you a bit of an indication, and it's a reasonably easy way to monitor whether you're mining your soil nitrogen and running down soil organic matter or not. And it's something you can do now today if you've got good records, whereas if you want to try and monitor that by measuring soil organic carbon, you'll have to wait another 10 years before you'll be able to measure a significant difference. So all you need to know are your crop and hay yields. If you have your protein contents, that's helpful if you have them, but if not, we've put some sort of average values in the spreadsheet. We need to know fertiliser inputs in terms of nitrogen and rough estimates of dry matter production of any legume pastures or brown manures that might have been in the rotation. So all we're doing is basically calculating this balance over time, and we've simplified it a fair bit. So we're taking into account nitrogen fertiliser, we're taking into account rhizobial end fixation in terms of the inputs. We're going to assume, or we're obviously taking into account the big output, which is in grain and hay. We're going to assume that in the low to medium rainfall zone, the inputs from rainwater and dust are balanced out by the small losses we have from denitrification and leaching. So we've ignored these ones. So this spreadsheet ain't going to work in southwest Victoria, I guess is what I'm warning you. And we're assuming that we have either full stubble retention or grazing of stubbles. We're not doing any baling or burning. If you're baling or burning, you'll need to add that separately. Okay, so I'm going to get back out to the spreadsheet. How's that for viewing?
That's good, James.
Cool. So in this one, similar to the other one, orange means we're putting an input and white means we're getting an output. So I've done an example here, but there's, as with the other one, there's a blank sheet for anyone who wants to do their own. So we put in, this is done on a paddock by paddock basis. So you need a new sheet for each paddock. So this is for one paddock over these years here. And this was the crop sequence in this paddock. And we also have to give it some information about whether if it was a legume. So if it wasn't a legume, you put in a 0. If it was a grain legume, you put in a 1. Hay, 2, and 3 a pasture, or if it was a pasture or brown manure, put in a 3, and it uses that to calculate the rhizobial end fixation. You then need to add your fertiliser products. So yeah, I've put in MAP, ammonium sulfate, and urea, but you can add more if you use different ones. So you need to enter them there. If you haven't used a fertiliser in any one of these places, you just need to put in nil because of the way the spreadsheet works. And so then it will calculate, it'll sum those up to calculate your fertiliser N input. Then you put in your grain or hay yield from the paddock in that year, the protein if you have it. If you don't have it, you can pop over to this table here, and I've got some rough estimates or averages of protein concentration for different grain and hay products. And so then that will calculate your nitrogen output from your paddock in grain or hay. Then this can be a bit tricky, but it's a situation of a rough estimate's better than no estimate. You need to enter what you think your biomass was of any pasture or brown manure that's in tonnes per hectare. So yeah, you can't go too wrong with this. Just have a rough stab. I think I'll put some values in here or typical sort of values. So yeah, for the Mallee, 1 to 8 tonnes is kind of the extreme, and 3 to 4 tonnes is pretty typical. Then it calculates an input for legume grain. So how much atmospheric nitrogen is fixed by a grain legume crop. So again, it's pretty rough rule of thumb stuff, and it's averages, but better than nothing. So it's assuming that we're getting 60 kilograms per hectare of nitrogen per tonne of legume grain fixed. But of course, that's also balanced out by your export in grain. Then for hay, we're assuming that we're getting 19 kilograms per hectare of nitrogen fixed per tonne per hectare of above ground biomass, and that your hay is about 2/3 of total biomass. And then for pasture or brown manure, we're assuming that we're effectively not removing any nitrogen in those systems. It's all staying in the paddock for use by subsequent crops. So we're getting our 90 kilograms per hectare fixed per tonne of above ground biomass. And then it sums or subtracts those in order to calculate an annual N balance. So the balance of that paddock in that year. So this, I'll just have to shrink it down a bit, sorry. So for this wheat crop, it had a negative nitrogen balance. More nitrogen was exported in grain than was added in fertiliser. Same deal for this barley crop. This lentil crop had a small positive N balance. More was fixed by the rhizobia than was removed in the grain. This canola crop had a small positive balance, and this wheat was the same. And if we go down and have a look at we've got a vetch brown manure in here, then we have quite a large positive input of nitrogen from that crop. And then over here, it just calculates the cumulative nitrogen balance. And if you're a visual sort of person, it graphs it all down here. So you can see how you're going over the long term. In the case of this example paddock, it's slightly negative. So over that series of years, it's 76. It's 76 kilos in the red. So you might want to think, well, maybe I should just be a bit more generous in nitrogen for this paddock to get the balance up to positive if I want to maintain my soil organic matter, but that's probably not too bad. Any questions on that?
So, James, what would you regard as being a serious negative balance for a paddock? Less than 100 continuously over the last 5 years or something?
Yeah, I think if you were over 100 and getting into the hundreds of kilograms, well, you'd probably struggle to rack up those big numbers over 5 years, but obviously the more you can go back. Yeah, I think if over a 10-year period you are hundreds of kilograms of nitrogen in debt, then that's a warning. And remember, we don't know exactly in our environment what's the most profitable or the best thing to do. But if we take our Chinese example as an indication, then running a small positive balance seemed to be the best place to be.
You must have explained yourself pretty well, James, because there's no hands going up at the moment.
It's just like with my lectures.
Yes.
I'll just go back to the prezzo.
So we are pretty close to being finished with the workshop. If there isn't any further questions that need to be answered from it. And that being the case, thanks for joining us. We hope you got something out of it. We're always looking to provide quality information to Australian growers through BCG and our partners in LaTrobe, and Harm's always been a great contributor, and Kate works pretty heavily in this side of things. So even though the COVID crisis has been a bit of a struggle in many ways, being able to experiment with digital forums like this is a really good thing for us, and looking for new online formats and ways to extend information that we get. So we hope we can continue to develop that. There's a survey link that I'm about to post in the chat box, which will we hope that you can fill out so that we can get some information and feedback on the way that this ran and help our funders provide better funding for better projects into the future. I'd like to again thank the Mallee Catchment Authority and National Landcare Program for the funding they provided to help run this workshop, and again to James, Harm and Kate for their time and their expertise today, and to all of you for joining us on the workshop. So thanks very much. It's been really good, and have a great night, everyone. If we don't see you.
And have a good rest of the season, everyone.
And the good rest of the season. Exactly right. Anything else to say, Harm and James? Kate?
Happy.
No, thanks everyone for
Thank
for
you.
listening. Thanks for contributing and putting questions on through the chat. If anyone needs help with their spreadsheets afterwards, myself or Kate, because she put in some pretty clever wizardry, which I may not be able to work, we'll be happy to help you out.
Yeah.
And anyone can feel free to contact us here at BCG if they need any more information. We can hopefully point you in the right direction or provide that information to you. So again, have a good night, a good rest of the season. Hopefully we'll be able to see everyone in person soon when we're all allowed to meet up and shake hands and be a social people again. Thanks very much.
Thanks, Tom. See you
Thanks, Tom.
guys. See everyone.